Hi everyone. Let's look at a seemingly simple problem, yet most of the undergrad students fail to solve this properly. In fact, a slight variation of this was asked in Physics Olympiad a few years ago, and there too not many attempted or got this correct. This problem involves some of the basic concepts in physics, and that's one of the reasons, in my opinion, why most of the undergrad students find it difficult. While you may enjoy solving this problem, goal of this channel is to present you with some hand-picked set of problems which will definitely help in improving the basic concepts that's needed to do better in some of the prestigious exams like IIT JEE India, gaokao China, Olympiad, or similar engineering entrance examinations. So now let's analyze this problem and see what's going on. As it is shown here, there is a rod AB and at some time t equal to 0, the string OB has been cut. So now the entire rod is hanging through OA. OA makes angle theta to AB. Now if you see what's going to happen, the moment this OB string is cut, this will try to go like this with, let's say, some acceleration alpha. And OA string will also try to move like this. Now since this is massless, so we can take the acceleration for the system here, which will go in this direction, which is perpendicular to OA, because of this movement. And let's call this acceleration A. Now, if we pick the x and y axis properly, then we will be able to analyze the entire things a lot more simply. So let's take this as axis x, and perpendicular to this is axis y. Because of alpha, there is an acceleration in this direction, which is alpha L by 2, because L by 2 is the distance from A to, let's say, center C. The acceleration A of the system is in this direction, hence we will also have acceleration A here. mg, of course, is acting downwards, so we'll write mg in this direction. Now once FBD is done, or the free body diagram is done, almost 50% of the job is over. But before we move on to write equations, let's understand one key point here. That at t equal to 0, instantaneously there is an acceleration alpha and also acceleration A. But there is no velocity or angular velocity in the system. And this is key point to understand here. And that is possible. If you consider one simple problem, when you throw a ball in the air, when it reaches the maximum height, at that height the velocity of the ball is 0. But is the acceleration also 0? The answer is no, because g is still acting. Or if you take a function, let's say y equal to ax square, and if you take the y prime, you get 2ax, and x equal to 0, this value is 0. And if you again differentiate this function, you get 2a, which may not be 0 if a is not 0. So if this is the velocity, then velocity is 0 at x equal to 0, but the acceleration is not 0. And that's what we are considering here, that instantaneously the velocity, the v and angular velocity are 0, but alpha and a are not 0. And this is one key point to understand here. And once this is understood, it's rather simple to write the equation. So let's write the equation first in x direction. We take sum of force vectors in x direction equal to mass into acceleration, sum of that. And mg the component of mg in x direction is mg. So if you see this is theta, then this is also going to be theta, and this angle will be 90 minus theta. You can work it out if you're not sure. So component of mg in x direction is mg sine theta. T is in opposite direction in the same axis, and that should be equal to m alpha L by 2 sine theta. Projection of A in the x direction is 0, hence we are not taking it here. Now at point C here, if we take the sum of all the torque, that should be equal to I alpha. And the torque here is only due to this tension, let's say T, and the component of T in this direction is T sine theta. Since mg is passing through C, hence there is not going to be any torque because of that, hence T sine theta into L by 2 should be equal to I alpha, and I here is 1 by 12 ml square into alpha. Therefore we get T equal to m alpha L by 6 sine theta. Let's call it equation 2. And if you take these two equations and substitute T here with this, you will get mg sine theta equal to m alpha L by 6 sine theta, and in bracket we can write 1 plus 3 sine square theta. Therefore alpha is 6g by L sine square theta divided by 1 plus 3 sine square theta. Let's call it equation 3. And now from 2 and 3 we get T equal to mg sine theta divided by 1 plus 3 sine square theta. Now this is the T final, means at T equal to 0. Now before the string OB was cut, what was the initial tension? Let's call it I. So it will be simply 2 Ti sine theta equal to mg. Therefore Ti is mg by 2 sine theta. Therefore the question is asking Tf and divided by Ti. So if we take Tf divided by Ti, we get 2 sine square theta divided by 1 plus 3 sine square theta. And this is the factor that we wanted to compute. When theta is equal to 30 degree, this value will be 2 by 7. Therefore A is the answer. Now we still need to compute A, which is the acceleration of the system, and that we can do by writing the equation in y direction. So taking again F equal to ma, the component of T in y direction is 0, so only mg is acting. So the equation will be mg cos theta is equal to ma plus alpha L component will be there, so m alpha L by 2 cos theta, and that will give me A, which is going to be g cos theta by 1 plus 3 sine square theta. We have already got the alpha also. So now we have all the unknowns in place, alpha, A and T final. Now if you want, you may want to write the equations for t greater than 0. So for t greater than 0, the v and omega will not be 0. Therefore, we will need to consider that also. So would you want to solve this problem when for t equal to 0 or t greater than 0? At least write those equations, and if you want, you can send it across to me on my email ID, or you can also post it in the comments, and I will get back to everyone as soon as possible. I hope you enjoyed this problem solving session. Thank you very much. See you next time.